Okay, we're going to look at the systems of equations in two variables. So for number one, if we want to determine if the ordered pair is a solution to the system, that means it needs to make both equations true. So to plug in, this is my x and my y, I'm going to have negative 2 is supposed to equal 3 over 2 times 2 minus 5. Well, 3/2 times 2, the 2's cancel, we get 3 minus 5. So yep, we get negative 2 equals negative 2. But it also needs to check in the second equation. So that's 6 times 2 minus 4 times negative 2. This is supposed to equal 20. So I have a 12. That turns into a plus 8 equals 20. It works. So we say this is a solution to that system. So then when we check the negative for 11, let's see what we get. 11 is equal to 3 over 2 times negative 4 minus 5. So 3 over 2 times negative 4, this right here will be negative 12 over 2, but that's really just negative 6. Minus 5 does equal, wait a second, it equals negative 11, not positive 11. So nope, can't work. So looking at part 2, again, what does it mean to be a solution to a system? So algebraically, the solution must satisfy all equations in the system, which satisfy means that it will make them true. Graphically, it's where they intersect. Again, remember that a graph is the set of all points that make an equation true. So we're looking at the intersection would be the points that make both equations or all three equations at the same time true. So let's look at number 3. It says solve using elimination or substitution, and explain why you chose that method. So when I look at this, I think that I want to use elimination, and that the reason for that is because it looks kind of hard to try and isolate any of the variables. So I want to eliminate something. So I'm going to actually multiply the top equation by negative 2, so that way I can eliminate the x's, because this would become negative 6x plus 14y equals negative 2. So when I combine the second equation with the first one rewritten, you see that x's will cancel. We're going to get 19y equals negative 19, which we can now solve. Divide by 19, we get that y is equal to negative 1. So we haven't solved the system yet because we need an x and a y that make the equation true, and that will be the ordered pair, which is the point where the two, really we have lines here, will intersect. So if y equals negative 1, let's plug into, I don't know, the first guy. So that's 3x minus 7y equals 1. And so we're going to substitute in place of that y the negative 1 that we just found. So we end up that we have 3x plus 7 equals 1 minus 7 minus 7. We get 3x is equal to negative 6. Divide by 3, we get x equals negative 2. And just one last double check for myself. Maybe I'll plug them into the second equation and make sure that it still gets something true, which I'm going to get, let's see, that would be a positive 12 minus 5. Oh, no, not positive. It will be a negative 12 minus 5, which is negative 17. So again, my solution will end up being negative 2 comma negative 1. That's the ordered pair. And again, it needs to check in all the, or both, the original equations, which it does. All right, let's look at number 4. Number 4 wants us to solve the system, again, using elimination or substitution, and explain why I chose each method. So I would use substitution on this one, and that's because I have a y equals equation. So this negative 2x plus 2 should plug in to the second equation in place of y. So that gives me 5x plus 3. I'm going to put that negative 2x plus 2 in there, equals 9. So if I distribute everything, that's going to be 5x minus 6x plus 6 equals 9. combining like terms, that's negative x plus 6 equals 9 minus 6 minus 6. We get negative x equals 3. Divide by negative 1. X equals negative 3. And I still, again, need to find my y. So I want to plug this in, and I'm headed towards the top one again, because it's kind of easier there. So I'm going to have that y equals negative 2. Stick in negative 3 for my x, plus 2. That's y equals 6 plus 2, which equals 8. So it looks like my solution should be negative 3 comma 8. And again, I would just double check that into maybe the second equation and make sure that it makes it true. So 5 times negative 3 is negative 15, plus 24 makes 9. So it sounds good. So the systems that we were just looking at, they are all linear. And when we have a system of equations with two variables and they only have an x and a y, so they're kind of this form, ax plus by equals c, which is a single x and single y, then you're talking about lines. And there's a couple different ways that the lines can happen. And so what it's saying is that you could have two parallel lines, you could have a single line, or they could intersect each other. So two intersecting lines, those are what we were just looking at really, because they have, the solution is 1 point. They intersect at 1 point. So there's one ordered pair that makes the equation true. Now if you have two parallel lines, they are never going to intersect, so they're not going to have any point in common, so there's no solution to that. Now if it's a single line and it was a system, that means that it's the same line. So sometimes you might draw that as like a line on top of another line. And for that one, we're going to have an infinite number of solutions. And the reason you could see why is because they're going to intersect everywhere. So every point that's on the line is a solution to the system because it satisfies, of course, both of those. All right, so the last two questions, and you're going to see these a lot in the rest of the homeworks, are going to have some sort of review question. So if you look at number 6, it wants you to look at the function f of x equals the cube root of x minus 2, and it wants us to find the inverse, and then we had to graph both of them. So the first thing about the graph, cube root is the guy that he grows a little bit slowly. You can plug a negative and positive to that. And the negative 2 has shifted to the right 2 spaces. So to sketch that guy, right 2 spaces, he's going to go right one, up one, left one, down one, but he's not going to grow very fast. So this is the function that it's talking about. That's f of x. Now remember, its inverse has to undo that, or you can imagine graphically, it's going to be a reflection over the line y equals x. So we could also identify the points, like this is 2, 0, and go up to 0, 2, because it has to reflect right over that. And you could do that for the other 2 points to get the picture. You can also solve it algebraically, and a few people like to write out, if we interchange the x and the y, that's x equals the cube root of y minus 2. Then you solve for for y. But what that does is helps you undo all the operations. So you can see that x cubed will be equal to y minus 2. Add the 2 in. So the inverse is x cubed plus 2. So you can see how that's undoing. And so this guy is going to be the graph that grows upward, goes faster, it's cubing stuff, and the plus 2 is shifting it up 2, which matches up with the green dot that it has right now, actually. So I'm going to sketch that guy. And so there's the inverse, which you could see it's a reflection over that line, y equals x, which was the identity. All right, for number 7, it wants us to find all the zeros of that polynomial function. So remember, if you want to find the zeros, you could try and factor, but this won't factor like our regular ways. And so there's a little hint that 1 is 0. So we can use synthetic division to help us out. So I'm going to write the coefficients of my polynomial and do synthetic division. So we're going to get 1, that multiplies, we get negative 1, that multiplies, we get 9, it's going to be negative 9, which makes negative 9, and we get 0. So then the polynomial that's represented with these leftovers will be 1 degree less than where we were, and so that's x cubed minus x squared plus 9x minus 9. That times, since we used a 1 here and got 0, 1's a 0, so the factor is x minus 1. Now we can take our leftovers and do some more than like division, but I noticed that this actually factors. The first two terms have x squared in common. If I factor that out, I'll be left with x minus 1. And then the second two have a 9 in common. So if I pull 9 out, I'll be left with x minus 1. So then this will factor, let's see, they both have the x minus 1, so I'm going to pull that out, and then x squared plus 9 will be the leftover part. And I'll have x minus 1 here. Now x squared plus 9 can't factor anymore because it doesn't have that minus in the middle, but we could try and just solve that. So we're trying to find the zeros. So I already know that this is going to have a 0 of 1, and that will have a 0 of 1. So I actually know its multiplicity is 2. And then this x squared plus 9 doesn't factor, but I can write x squared plus 9 equals 0. Move the 9 over. Move the 9 over. So we're looking at x squared equals negative 9, which if we take the square root, that's going to be equal to both the plus and the minus 3i. So we're going to get a positive 3i and a negative 3i for our zeros. And both of those will have multiplicity of 1. And you can see those are going to be my 4 zeros, which again, that makes sense because I was a degree 4 polynomial.